welcome to Mathematics Made Easier channel. This is your favorite mathematics tutor, COMFORTAMOAKOATTAH. Today, I'm going to take you through the various angle properties in a circle. So relax, pick your joters, and go through today's class with me. But before we come to the various angle properties of a circle, let's remind ourselves of the various parts of a circle. Good. Alright, so this is a circle. Put in my diagram. Okay. So this is my circle. Then we have a line being drawn. A line that divides the circle into two equal parts. So this line is called the diameter. Divide the circle into two equal parts. Then half of the diameter is called the radius. That is a line drawn from the center of a circle to any part of the circle is called the radius. So it means this is the radius. This is also called a radius. It is from the center O to any part of a circle. Okay. Then we also have the distance around the circle. So this distance around the circle is called the circumference of the circle. So this is the circumference of the circle. Alright. Then we also have a line drawn from one part of the circle to the other part. So a line drawn from one part of the circle to the other part is called a chord. Okay, then we have the region bounded by the chord as the segment. So this is a minor segment. Then we can also term this as the major segment. Okay, all right. Then also we can also say that two radii, that is, we have this from the center to any part of the circle, from the center O to any part of the circle, and an arc is called the sector. So this is our sector. Okay, two radii and an arc is called the sector. I believe you remember all these words because you've learned this. Okay, we are just trying to remind ourselves of the various parts of the circle. Having looked at it, now let's come to today's business, that is the angle properties of a circle. So that is circle theorem. Angle properties in a circle. We're going to look at the various properties. Okay, so let's pick the first property and talk about it. Okay, So property number 1. Property 1. Let's look at what property 1 says. We have our circle. Okay, pardon my circle. So the angle, a chord, or an arc subtends at the circumference in the same segment. Are equal. So we have A, B, and C. So we can say that A is equal to B is equal to C. That is, let's state it. The angle, a chord, or an arc subtends at the circumference in the same segment of a circle are equal. Okay, so let's give an example. In this case, if I have an example like this, and this chord is subtending an angle at the circumference in the same segment, and I have this angle to be 30 degrees, it means that, and I am to find this angle, it means that since the angle, a chord subtends at the circumference in the same segment are equal, we can say that B is equal to 30 degrees. So that is the first property. Alright, so let's look at the second property. Property number 2. Okay, number 2. Okay, so we have our circle again. Then let's draw a circle wall. Okay, so we have a nice circle. Then we have our chord. Then this chord is subtending an angle at the center of the circle to the circumference. Okay, so with this, we have this place to be A and this place as B. I can say that A is equal to 2B. That is, the angle a chord subtends at the center of a circle is twice the angle it subtends at the circumference of the circle. So let's state it. The angle, a chord, or an arc subtends at the center of a circle is twice the angle it subtends at the circumference of a circle. circumference of the circle. Alright, so with this we can also give an example as if this is so let's write example. If this is a circle and we have an angle subtending the center O, this line AB, and it's also subtending the circumference of a circle. If this angle is 60 degrees, what do you think this angle will be? I'll leave you to answer that. Based on the theory we have stated that the angle a chord subtends the center of the circle is twice the angle it subtends at the circumference of the circle. Alright, so with this we are done with this theorem 2. So let's look at the property number 3. So property 3. Alright, with this property 2, I have my circle, then I have my cyclic quadrilateral inside. Okay. Alright. So this property also states that this cyclic quadrilateral, the opposite angles, we can say that the opposite angles, the sum of the opposite angles is equal to 180 degrees. That is, they are supplementary. So we can say that A plus B is equal to 180 degrees. That is, angles at the opposite angles in a cyclic quadrilaterals add up to be 180 degrees. Let's look at an example. So examples. I have my circle and I have my quadrilateral inside it. So it becomes a cyclic quadrilateral. Alright. Then I have this place to be 70 degrees and this side to be C. What do you think our C will be? Based on the theory we just stated, we said that opposite angles in a cyclic quadrilaterals add up to be 180. It means 70 degrees plus C is 180. So making C the subject, we are getting 180 degrees minus 70 degrees. And that is giving us great 110 degrees. Alright, I believe you are enjoying the class. Let's look at our fourth property. So property number 4. I have my circle, then I have my okay, so I have my circle, then I have my tangent. It should touch the circle. Then I have my chord. I have my chord, then angle over here. So let's say we have 50 degrees. This angle, and we have this place to be A, and they are saying find the value of A. So what do you think A will be from the theorem we just looked at? We can say that A is equal to 50 degrees. The angle between a chord and a tangent at the end of the chord is equal to the angle at the opposite segment. So A is also equal to 50 degrees. Great. Alright, so thank you. Let me give you one question. And you apply the various properties we've looked at to solve it. So try this. You are going to apply the various properties we've looked at to solve this question. Okay? This is 100 degrees, and this is V. This is W, Z, X, Y. And this angle is 110 degrees. Alright, so the question is, in the diagram, you have the center O. So in the diagram, O is the center. O is the center of the circle. Of the circle, W, X, Y, Z. We have XZ and WY intersecting at V. At V. Okay, then angle XOY is equal to 110 degrees, and angle YVZ is also 100 degrees. Calculate I. Angle XZY. I. Angle WXZ. Alright, thank you so much for your time. I believe I'm going to receive these answers at the comment section. Practice more and solve more examinable questions. Solve more past questions and the circle theorem. Thank you so much for your time. I believe you are going to solve more questions under this. And with that, you are going to become perfect. With circle theorem, you need to apply the various properties when solving questions under circle theorem. So get the properties and know when to apply them. Do not forget to subscribe, like and share this tutorial as well. Till we meet again, please stay safe and learn hard. Bye.